Good day, we are now on our video number 11 and it is all about Mann-Whitney U-test. Mann-Whitney U-test is used to compare differences between two independent groups when the dependent variable is either ordinal or continuous but not normally distributed. Unlike the independent samples t-test, the Mann-Whitney test allows you to draw different conclusions about your data distribution. It also required that the two random independent samples, the data is continuous. In other words, it must in the principle be possible to distinguish between values at the nth decimal place. The scale of measurement should be ordinal interval or ratio. For maximum accuracy, there should be no ties through the test like others has a way to handle ties. So we have now here our data sets and a situation. Consider a randomized controlled trial evaluating a new antiretroviral therapy for HIV. A pilot trial randomly assigned participant to either the treated or untreated group. The viral load, quantity of virus per millimeter of blood in treated versus the untreated groups. The 50 samples for treated group and other 50 samples for untreated group and a total of 100 dataset sample. To start with our computation, let us first distinguish the objective. Is there a significant difference in the viral load between the group of treated with the new therapy versus untreated? The null hypothesis, there is no significant difference viral load between the group of treated with the new therapy versus untreated. The parameters, significant level 0.05, the confidence level at 95%. So we have here are the Mann-Whitney U-test calculator, sample 1 for the group A and sample 2 for the group B. Significance level to 0.05 and the two-tailed hypothesis. So the value of U is 748.5 and the z-score is 3.4538. The p-value is 0.00056. The result is significant at p is less than 0.05. This is the narrative discussion. Let's move on to the result number 1. The mean of group A is equal to 81.12, while the mean of group B is 70.9. The value of group A is greater than the mean of group B. The result number 2, the z-score is 3.4538. The p-value is 0.0056. The result is significant at p is less than 0.05. That means that the null hypothesis is rejected. Therefore, there is a significant difference in viral load between the group treated with the new therapy versus untreated. Our data analysis is the given dataset had been tested with Mann-Whitney U-test since each group will consist of different participants or respondents. Each group does not tested with Kolmogorov test for normality because U-test does not require it. Testing two datasets with U-test samples yields to a z-score of 3.4538, which is less than a significance level of 0.05 and a p-value of 0.00056. Since the p-value is less than the significance level, the hypothesis will be rejected. Therefore, there is no evidence of the viral load between the group of treated with the new therapy versus untreated.